Going to moon was an ambitious program for us when we way back in 1980s. We had small rockets called the PSLV, which has very small capability. Then we decided that it's really important for us to explore moon and then create some science out of it. While we were focusing on missions to serve the public in terms of data, the communication, and many other capability, and we built our own rockets, our own spacecrafts, but the time has come for us to create exploration science in looking at planetary systems. Thus came the mission to moon, the Chandrayaan-1. With the very limited capability of the rocket, we designed a spacecraft that can go to moon. And with a capability of just 1 ton plus capability of launching to the Earth orbit, we accomplished the first moon mission. And followed was the Chandrayaan-2, where we ambitious program of landing on the moon. By the time we had a new rocket, which has a higher capability, and then the final, the Chandrayaan-3, where we actually achieved the soft landing on the southern side of the moon. The first mission, Chandrayaan-1, was very exciting for us because it was done on a rocket called PSLV. It was designed to launch satellites in the polar orbit. That's why the P stands for. But then it has launched the communication satellites. It also launched a mission to Mars, where we were successfully injected later. And this mission was so important for us because the mission was the first time in which we brought out new algorithm to go to moon by going around the Earth for multiple times and then achieved a lunar capture orbit. We also had instruments from USA as well as from Europe and Indian instruments, and ultimately detecting water on the moon. And very first time, we also put an impact probe on the moon craft and then achieved the first ever landing on the moon, but that was not a soft landing, it was a very hard landing. But this gave us a lot of insights on how to understand moon. The science that came out of it has been phenomenal. The moon mission Chandrayaan-2 was very important for us. By the time that we achieved this Chandrayaan-1, the thought about how to do a landing mission came up in the science community in India. And we had to do this at extremely low cost. And the rocket for that was just getting developed. The launch vehicle Mark III has just completed 3 launches of its inaugural launches. It is coming out of the infant mortality and things like that. And the very first operational mission of the rocket, we decided to put the moon mission. And the Chandrayaan-2 was designed with a lander and a rover. And this was, again, a piece of frugal engineering, and including the propulsion, the throttle propulsion, the algorithm to go and land on the moon, the sensor suits, and the scientific instruments all were designed and developed in India using our own laboratory. In this mission, there were no cooperative payloads hosted. Everything was done in India. And you know that the whole mission achieved tremendous success. We were able to go to moon in the very first attempt, capture on the moon, and we placed the satellites in the moon orbit. Landing process happened very well, but then the last phase of the landing process, there were some glitches in the software which resulted in the hard landing of the craft on the moon. But the orbiter, which had the best of ever cameras, which was a 25 centimeter resolution camera, brought phenomenal images of moon. Today, that images are being used world over by all agencies to plan for the landing on the moon. And also, radar images of the moon gave a lot of insights on the science on the moon, especially how the activity on the moon surface is happening. And this science data is actually available to public through our data repository, which is being shared across the world. The moon landing really still eludes us for many years. You know that 2019 we did the Chandrayaan-2 landing, but the actual successful landing on the southern side of the moon was achieved in 2023. It was 4 years since then. We had to understand what went wrong with the Chandrayaan-2 mission and then build another Chandrayaan-3 with the same lander called the Vikram and the rover called Pragyan. And we built it with very, very rugged algorithm now and new sensor suits, which includes different instruments to measure the navigation aids and a multi-sensor fusion algorithm that actually enabled us to make a soft landing. We were not actually able to identify what exactly went wrong with the Chandrayaan-2 because the data analysis didn't indicate one reason. But then we looked at many, many reasons that could have gone wrong and made it stronger, better in design. And we finally accomplished the soft landing on the moon. And the whole trajectory of decelerating the craft from almost 1.7 kilometer per second speed to a vertical landing is really a challenging thing. And for us, this whole of this process was enabled through cooperation with USA, the NASA. And I can tell you that some of the support that we received from JPL Caltech in enabling the algorithm development, the measurements that we did while it is on the path to moon, and also the final landing process, the communication infrastructure that was shared between USA and India is something phenomenal. And that continued to help us to develop future science missions as well. The landing was again very historical in India because it was been a globally watched event. Landing of a craft on the moon, especially the southern side of the moon, has been really important for us. The Prime Minister of India was us at BRICS Summit on that day, and he came online and watched it live. And I was there, being at the control center. I was very proud. And this was one of the YouTube streamed video, which was seen by 8 million people simultaneously live telecast on that day. And not just 8 million people actually saw it on the YouTube, but also across India in schools and colleges and institutions, it was seen by people and public. It changed the way in which Indian people looked at scientific accomplishment and actually changed the approach to STEM education in India. And this was something which you say is very, very important for us. It was not just an event to celebrate, just landing on the moon, but the science was very important for us. And while we planned this mission, Chandrayaan-3, the instruments to look at moon was also designed and developed in the past years, were built and then launched on board. And we had 4 instruments in the orbiter, 2 instruments on the lander and the rover, and also 1 instrument on the orbiter to understand Earth, to look at it as a planetable habit. So essentially, the instruments were looking at the regolith to understand the thermophysical properties. We were looking at the moon atmosphere to understand its electromagnetic behavior. We were also looking at the moonquakes as a seismic instrument was launched on board. We also had a sensor which was piercing the moon surface and measuring it to understand the thermal conductivity and other effects on the moon surface. We had 2 spectroscopic instruments on the rover, which actually looked at the regolith and then understood its elemental composition. One was based on alpha particle spectroscopy, and then another based on laser ablation and its spectroscopy. All these instruments were designed and developed in the laboratories and universities in India, and we were able to build and launch. All of them worked very well in the moon mission. The rover, it's a very cute rover. It was just 35 kilogram in mass. It was called Pragyan, and it came out. It was a very tense event for me when I was at the control center to deploy the rover and then make it land. It didn't come out in the first attempt, I must tell you. But then we were able to command and bring it out very safely. It traversed on the moon surface for almost 100 meters, avoiding obstacles, rocks, and other obstacles, and found out conducted experiments using the spectroscopic experiments at multiple locations, almost 10 locations. And all the data that was received is actually cataloged, and we have huge amount of scientific outcome out of this. But you must tell you that this mission was very important for us, especially planning the mission and making it survive for 1 lunar day. On the day it was landed, the 23rd of August 2023, it was the opening of the day on the moon. A day on the moon lasts only 15 Earth days. And after that, there is a night which is going to happen for next 14, 15 days. So we have to start on the first day, morning of that day, and then end it on the evening of the day, which lasts 15 Earth days. And that 15 days, we were able to conduct all the experiments. But then we made the spacecraft to go to sleep, and it didn't come up after the end of the night. So of course, the design of that was not meant for that, but the entire experiment was planned and then completed successfully. But the most important was, again, in terms of innovation and the way in which we are able to do things frugally, is characterized by what we did afterwards. On the last day of the mission, I asked my teammates, can you do something different that we never, ever planned? Then we thought about an action. Why don't we restart the lander and take it up and then do a hop test? It gives you a reprogramming capability and ability to take off from the moon surface and then do return to Earth program. So we entirely reprogrammed the whole craft, sent commands from there. We did a simulation the whole night, and next day morning we uploaded the new program and made the spacecraft to restart the engines and hop off and then land it in a little far distance. Just gave us a confidence on how to do such missions, and something which was never ever imagined. We also did another interesting experiment of bringing back the orbiter, which was going around the moon back to an Earth orbit, which was again never planned before. So we used the propulsion to bring it back to Earth so that it doesn't become a debris on the moon surface. So this was something very unique work that we did during the moon mission. Today you can see the image that we took using Chandrayaan-3 of the craft of Chandrayaan-2 on the surface of the moon is something very interesting. So we imaged Chandrayaan-2 using Chandrayaan-3. I would like to tell you that same time when this was going on in India on the moon mission, we were also working on a mission to understand sun. It's called Aditya. Aditya is the name of sun in Sanskrit. So Aditya L1 has a mission to go to Lagrangian point. L1, Lagrangian point is a location between sun and earth where the gravity neutralizes, and you can put something there, it stays there for a long time. But this is almost 3 times the distance of Moon from Earth, and you need to travel to that place. And so precisely the guidance algorithm, the propulsion system were all designed within India. And we also put instruments to study sun in various ways. We had a coronagraph, we had a soft X-ray instrument, we had a hard X-ray instrument, we had alpha particle detectors, we have magnetometers to understand the solar magnetics and many others. So study sun in multiple ways. This is a very unique payload that we had on this instrument. Also ultraviolet observations. And you can see those observations of the moon using our ultraviolet telescope produces wonderful images. So today this data is being streamed back to Earth, and our solar scientists are sharing this information with scientists across the world to study the coronal mass ejection and related issues with respect to Earth's atmosphere. But I would like to bring your attention to the Mars orbiter mission, which we did sometime before that. And it was a very unique mission, the very first time India achieved a successful mission to orbit Mars. The images that came out of the Mars mission is very stunning. Today we have a three-dimensional image of the Mars, one of the best of ever produced by any spacecraft around the Mars. We also built and had cooperative missions with other spacefaring nations. As you know, that NASA ISRO synthetic aperture radar satellite is just launched, and currently it's undergoing throughout and testing. The first images of synthetic aperture radar images in the L band from the US side is just been released, and the S band is done by India. The launch happened at Indian Spaceport Satish Dhawan Space Center. I'm really thankful to the JPL NASA team for enabling this cooperation to happen in India and to have this launch. It's one of the costliest ever Earth observation satellite ever built, and we are happy to host it on board one of our rocket called GSLV and place it very successfully in orbit. And the biggest ever deployable antenna on board has deployed in this satellite, which is a 12-meter deployable antenna. And we are also building similar cooperative payloads with other spacefaring nations. We have a mission with Europe. We also have a mission with JAXA to build scientific missions in the future. Our ambitious program of launching humans to space has been going very well. I just heard about the mission to International Space Station. Our astronaut Shubhanshu Shukla has been there for 2 weeks and came back very safely. But then traveling in an Indian craft on board an Indian rocket is something that we are working on for the last few years. But it's a tough job, as you know, that sending humans to space is not easy. The first step of building a rocket, which is very reliable and safe, is already been done. It's called human rating of the propulsion system. The rocket has already been completed. We did many tests in the ground to prove it. But building the space module, then developing the human spaceflight capability, especially with regard to environmental control and life support system, the crew escape system, the algorithms to identify failures and emergency detection and safety, all of these are going through, and we hope that by 2027, we should be able to do this mission very well. We also created a space vision for next 25 years. Looking at the emergence of the space sector in India, especially the work that we did in Chandrayaan and Mangalyaan missions really inspired young people in India to take up space as one of the important career. And this is something very exciting for all of us. And we have today 350 startup companies in space sector, building rockets, building satellites, developing applications in India. And this area is showing up significant economic activity currently. And it's something which we would like to use. And we have put a target for ourselves in India to scale up this economy of space economy really substantially higher, from a 2% contribution to the global space economy to at least 10% in the coming years. And there is a policy framework that we built to enable private space actors to come into space and then work in this sector. This has helped us to develop a space vision for next 25 years. The essence of this vision is summarized here to show that we have a target of landing humans on the moon by 2040. We also developed a plan to build our first space station called Bharati Antarisha Station and launch it by 2035. And we also declared that we are going to have a series of moon missions. Chandrayaan 4 and 5 has already been announced and funded by the government to build and launch. We also have having plans to go to Venus. And new rocket, primarily based on liquid propulsion or reusability, has already been announced, and we are building it now. New launch pads are under construction in India. So it means a huge investment space is coming up as part of the governmental investment. But equally important is the interest in private sector to come up and then contribute to space station and other related activity. I would like to tell you a little bit about the missions to moon now. The Chandrayaan 4 is an interesting mission where we are going to do, once again, very frugal mission to go to moon and bring back samples. And that's the Chandrayaan 4. Primarily based on the Chandrayaan 3 architecture and the propulsion system, we have developed an architecture by which we can go to moon. and come back with a sample collected, fully done robotically. And the next mission is the Chandrayaan 5, which is a joint mission between ISRO and Japan JAXA, where the lander will be built by India. The rover, which is almost 350 kilograms, will be built by JAXA, and the launching will happen on an H-2A rocket from Japan. And we are looking at landing exactly at the South Pole and conduct experiments for a duration of not less than 100 days. So this is again an interesting mission which is currently going on, and the cooperative work and scientific work of this is progressing. I would like to summarize saying that the activities in space sector and private is really picking up. You can see some of the launches of the startup companies. And in a few years back, there was no possibility of some private company in India building rockets, engines, and launching them from using our own facilities. It is now happening. At least 5 to 6 companies are building their own satellites, especially small satellites. The sensor suits, the payloads, the applications are being developed in the private ecosystem. So there is an interest in universities and research establishment to work in the private sector, and this is really shown up by the new actors coming into space. And this is an interesting era in the space sector in India. I would like to tell you the landing of the Chandrayaan 3 on the moon really created big headlines in India. It has been celebrated as one of the important events defining the technological capability of our nation. And it is used in an effective sense to inspire young people, because it's very important that the next generation is prepared to take up such challenges in building complex systems. And when you do it ourselves, and really know the pain of doing it, and doing it at extremely low cost, because the funds in space research is not just that easily forthcoming. So it's very important to inspire young people and then do this. So we go around and then talk about what we did in such a low-cost engineering solutions that are really the characteristic of an Indian engineering capability. And equally important is the role of women in STEM and education and scientific research. And this photo shows the Prime Minister congratulating all the women scientists in ISRO who contributed to building Chandrayaan. And I would like to conclude telling you that our journey of building space systems and complex missions of this nature has been a part of the learning that we had together. And it's for the collaboration that we had with many, many spacefaring nations in building the capability of India and bring out useful results and missions for the benefit of the humanity. Thank you so much.